guys, my name is Ravisha, and I'm an intern at Google, and my hosts are Ron and Gan. And we're going to be presenting WebBoot. A little about me, I'm from DePaul University back in Chicago. I'm doing a bachelor's in computer science, and I'm going into my third year. And then this is my podmate, Lewis.
Hello, guys. My name is Louis, and I work together with Avisha as interns at Google. I'm a rising junior at Dartmouth College on the East Coast.
So a little about WebBoot. So imagine you have a laptop without an operating system. What would you like to run today? You can run any operating system that's unstored on web. You want to run Chrome OS? All you have to do is type WebBoot Chrome OS. If you want to run TinyCore, you can run WebBoot TinyCore. The choice is yours. What WebBoot provides is it's like never seen before. You don't need the typical materials that you would need before, like a bootable USB stick, a CD, a DVD, or a hard drive. What WebBoot does, it stores everything in RAM and lets you boot any operating system you would like to.
So WebBoot is an open source tool, and just like most of the things here, it's open source, and it's used to boot live operating systems from the web. So it downloads and loads a new operating system. WebBoot grew out of NEF, and NEF is the project that my team at Google is working on, and we implemented WebBoot in Golang. WebBoot is exceptionally fast compared to other methods of booting, and we actually timed it, and it took about 22 seconds to compile the userland and to create the initramfs. Since WebBoot is open source, that's the link to our repo, and if you guys want to contribute to our project, we'll really appreciate that. So before WebBoot, what were the typical steps of booting into an operating system? So first of all, the classic way, you had to buy a USB, right? Then you had to download an operating system. Then after downloading an operating system, you had to create a bootable, of which this is sort of like complex to some other people who are not in tech. After that, you had to find a new laptop to sort of like boot the operating system on. And you had to change the BIOS to sort of like boot from the USB. Then after that, you had to boot into the new operating system. And in this process, you had to potentially risk wiping out your hard disk. It happened to some people. Then with WebBoot, what you have to do, you just type WebBoot and you type the OS. So let's say you want to boot TinyCore, you can just do WebBoot, then TinyCore. If you want to boot Ubuntu, you just do WebBoot, then Ubuntu.
If you look on Google search and you type how to flash a USB, there's 66 million searches. 66 million searches to one. WebBoot, TinyCore, WebBoot, NEOS. So why? WebBoot shows that you can use persistent memory devices to boot any operating system you like. So what this does, it stores the operating system in RAM, and what it does is it goes to the next, and then the next kernel would be able to look at the memory that's stored and be able to take and extract anything that they would like packages, graphics, all of the things that the operating system has. It can look at it and it can use it. It's a new way of booting an OS. And it also provides the user flexibilities. One of the things that my host told me about when I first joined this team was that two examples. Imagine if you're a journalist back in a country that doesn't have that much privacy, and you're writing a journal article and a police comes knocking on your door. You can't, as of right now, when you close your laptop, things are stored in your hard drive. You can't just wipe them out. With WebBoot, you can have everything. You can shut off your laptop. Everything is gone, so the police wouldn't be able to have access to it. Software engineers, we like debugging things. What if you want to go into Chrome OS one day and just kind of go in and look at it and debug things and then leave? Well, with WebBoot, you can do that. You can get into any userland you want and be able to do any of those things. So we have a little demo, and we'll show you that right now.
So right now it's booting into uroot, which is like where we start from. Then somebody's going to type webboot, then tinycore, which is the version of the Linux we want to boot, then verbose to sort of like print out any messages that come out.
So my job in this was setting up the networking. So what I did was I kind of worked with DH Client and I worked with downloading the entire ISO from the web. So as of right now, our Wi-Fi is perfect. It can connect to any Wi-Fi network that has password or an Ethernet code. My DH Client kind of looks for IPv4 and IPv6. There was an existing DH Client, but we implemented it to, as long as it connected to one of them, we were able to download and load any other operatings and download the OS from the web. So it's configuring it, it's getting the message, the DH client is getting the message from the server, and after this, it's gonna start downloading the file.
Yeah. Okay, the stuff. Okay. Okay.
Yeah, it's going.
Yeah.
So retrieving
So
the
retrieving a file is like downloading the file. Then after that, it will kazak into the tiny core. Almost. Yeah, there we go. Yeah, so downloading the files was kind of like a little bit slow, but there we go. So at the top corner, you can see it's sort of like loading extensions. It sort of like reads from that persistent memory device we sort of like wrote to earlier. And after loading extensions, it boots into TinyCore. So
And it shows all the things that the TinyCore has. You can have a terminal. It has everything that TinyCore normally has.
you can go next.
How do I get out?
Yes.
Okay.
Yeah. So let's go.
So like I talked before, mine was Wi-Fi and DH client. So what I did was we had networking stuff that we had to deal with. So my job was to connect to one of the interfaces, whether that was Wi-Fi or Ethernet, and then get a message back from the server and connecting that. After that, I started downloading the ISO from the internet onto a persistent memory device, storing it all in persistent memory device.
Then after she stored the files in the persistent memory device, I had to sort of like mount that device on a file so that I could access the kernel and the initramfs files. Then after accessing those files, I sort of like had another function which sort of like process the command line. So different operating systems require like different command line parameters. So we had to process the command line with respect to the operating system we wanted to boot. So you can either pass the command line parameters as a flag, or we can automatically put them, we write them inside the command. Then after doing that, I wrote the function to kazak. It's kazaking into the new operating system, and that's what loaded the new operating system.
So some of the challenges that we faced, the personal challenge was not having a lot of documentation on persistent memory. Everything that we looked up on Google search or anywhere dealt with persistent memory devices with DACs. We didn't use DACs, we just used persistent memory devices. Another thing is security. So right now our web boot, we have an internal map and we have a link to TinyCore, or we would have a link to Ubuntu or any of those things. But web boot is supposed to provide users flexibility of downloading anything they want, whether that's Ubuntu version 1, version 1.1, whatever. But that comes with a lot of security questions. What if a hacker creates a new website that looks just like Ubuntu, has everything that Ubuntu has, and then wants web boot to run that operating system? Well, that can be viruses, virus prune, and all of those things. So we really need help with security. Another thing is PMEM drivers are not enabled in most Linux kernels. So when we boot Ubuntu, they don't have PMEM drivers in their kernels configurations loaded. So it's like, what came first, the chicken or the egg? The first kernel has persistent memory in the side for the next kernel to look at, but the next kernel doesn't know how to deal with that. So that's another issue that we're running into.
So the future work on our project is to boot more distros. Right now, we can only boot TinyCore. And to boot TinyCore, we had to use our kernel and enable the persistent memory and recompile the kernel to mirror that of TinyCore. But for distros such as Ubuntu, they are big, and it's really hard to sort of like recompile their kernels. So we want to boot Ubuntu, Arch Linux, Debian, and Chrome OS, and some other operating systems. As she talked about, security is another issue we want to deal with. And lastly, we wanted to sort of like install it in core boot. Right now, we are using a USB where we boot from, but in the future, we want to actually install it in the hardware.
And then we just want to say special thanks to our team, Ron, Gon, Ryan, Prachi, and Chris. Any questions?
Yeah, please queue up at the microphones again.
I tried to build it and it didn't work. Can you come help me?
You actually tried to boot it?
Yeah, to build it. And it's cool. It's some Go issue.
You need to buy a support plan for that.
I think we can look into that
Yeah.
after the presentation.
Yeah.
Help you get it to work.
I have a question. How do you download? Do you use HTTPS?
Right now,
Yeah.
I don't think we're using HTTPS, but we plan on using HTTPS because it's secure. This was just a proof of concept in a way, and we hope to develop it more and use HTTPS.
Okay, yeah. There is a project called NetBoot XYZ. If you're not familiar with it, it has checksums and things like that that do not require you to use HTTPS and it also has a bunch of like the latest Ubuntu releases and Debian releases and things like that. Might be useful to corroborate on that.
Okay, thank you. I'll look for you after the presentation.
Yeah, I'm
Take note.
sitting here.
Yeah, thank you.
Thanks.
How long did this take?
So our internship was 12 weeks. So the first half of our internship for 6 weeks, we kind of did a lot of research, kind of did it manually, and we looked into like persistent memory device because when we were doing this project, we didn't know how to work with it. First thing was we can just pack it all in the initRMFS and kind of load it, but then the initRMFS would become too big. So then we kind of came up and did the persistent memory way, and it worked. So we kind of went along with that. So the last 6 weeks, we kind of really tailored towards WebBoot.
All right, I'm going to mention they began the summer never having seen Go. They knew Java, never having built a kernel, didn't know what an initRMFS was, didn't know what DHCP was. In fact, every single thing you see up here is stuff they had to learn from scratch, which is why I was so impressed with this project.
Aw, thank you.
Thank you, Ron.